Hey, so this is actually, I'm making the last video in Unit 8 for me. It's topic 8.6 though, which isn't the last one topic, and it's structure of acids and bases. I'm not happy or I'm not looking forward to this video. It is not my specialty. I'm going to reference Dingle's notes, page 8, 9, and 10 and 11. And basically, I'm just going to explain to you what his notes mean to me. All right. So I need you to not ask me too many questions about this, but I think I got it. Share my screen. There. Okay, so I'm just going to go to the notes. You need to look at your notes, right? I have read these several times. I read them last year to try to, what? Because this is, I don't know. I'm just a teacher. I do know everything. Now, what I do know is we've got our, we're talking about structure of acids and bases in relation to strength. Okay. We're going to keep this simple. You will see, if anything, one question about this, if anything. But we know that this is a strong acid, and this is the conjugate base of a strong acid. Therefore, conjugate of a strong acid. Therefore, it is stable because it does sit in solution, okay? So it's stable. It's going to stay there. He's cool there. So look here. In order for nitric acid to be considered a strong acid, the reaction needs to effectively proceed only in the forward direction. Okay, suggesting that nitrate does not go back and take that hydrogen, okay? Meaning it is a very weak base. That is because the nitrate ion is stable. It's got resonant structures. The electrons are delocalized, spread out over the ion. Because it's, so what we get from that is that strong acids, I don't want this color, is that strong acids and bases have stable conjugates, okay? That's what you need to get from that right there. The more oxygens in the atom, in the acid, the more stable the acid. I should probably get my own paper, is what I'm realizing, okay? Because oxygens are very electronegative, and when they go, so listen to me here, oxygens are very electronegative. So the conjugate base, when it has a lot of oxygens, is stable with that negative charge. Okay. Now, if I was to take this down to only 2 oxygens, I have a weak acid. Therefore, this is not very stable in solution. It doesn't readily go in that direct, give away its hydrogen, because without it, it's not as stable. So the reason there would be because it's lacking in oxygen, and it's lacking the electronegativity of that oxygen, which is making it less stable with that added negative charge. Okay. Now, where that I got. Now we've got carboxylic acids, okay? I'm just looking at whatever's highlighted here. A carboxylic acid contains a COOH, all right? Here, look, COOH, COOH, COOH. So it always comes in that form, all right? Now what you're going to see is this R right here just means the rest of the molecule. So here, my orange is my R, the blue and the green. Okay, so that just means the rest of the molecule. And what we see is that as the rest of the molecule gains, right, as R gains C's and H's, it becomes weaker, a weaker acid. All right, that's what we see, because the lower the pKa, am I right there? Yeah. Increasing strength, right? The higher the Ka. Yeah, I'm sorry. I was right, but for a minute I thought that doesn't make sense. Yeah, the higher the Ka, the higher the Ka, the higher the strength, right? So what we see is that as the rest of that molecule gains C and H's, it becomes weaker. Therefore, what is left behind here when we take that H away, this is more stable than what is left behind here when we take it away, and here when we take it away. We know it's less stable. Why? Now, this is what I need you to ask me questions about. Read the notes. You're going to see what I see. Because I can infer, right? Just like you can. But it says that this species, the larger it is, it pushes more electrons towards the negative part of because this is going to become negative, right? And those extra electrons in these negatives are less stable. This has less of an inductive effect, all right? I'm really beginning to start understanding it, so I can answer some questions based on what I'm understanding, okay? And this has a greater inductive effect. And that inductive effect of pushing those electrons towards the anion is not a stable thing. So it doesn't form. So it's weaker in relation to its structure. All right. And however, so notice here, what we have is our ethanoic acids again, right? We've got that, or our carboxylic acids. Okay. Notice they all end in oic. They are carboxylic acids. They contain the COOH, right? This H falls off to leave COO negative. All right. So we talked about as the rest gets bigger, it gets weaker. But now what we see is we are replacing hydrogens with chlorines. And the more chlorines, the stronger. What does that mean? That means that what is left behind is more stable conjugate base. All right. And it would have to do with the high electronegativities of those chlorines being able to handle that negative ion. With the negative charge, rather. Okay. Yes. Pretty good. Pretty good for not feeling too confident, huh? Oh, wrong button. Oh no. And stop share. End meeting. Bye guys. On to unit 9.